Hola a todos, soy Javier Poveda y esto es De Bien TV, el canal donde te lo vas a pasar de bien mientras aprendes geografía, historia del arte y este año un poquito de economía y de empresariales. Este vídeo va dirigido a mis alumnos de primero de la ESO de sección del CEIPSO Encinar de Torrelodones. In this video we are going to learn how to solve weather map problems and altitude problems. So first we need to be clear with the theory. Okay, we have to know what are we looking at when we look or when we are observing a weather map. Let's start. First, we need to know what is this, a big A or a big B. A big A means we are in front of an anticyclone. A B means this area is a depression, also called a cyclone. An anticyclone means that it is an area of high atmospheric pressure. What is a high atmospheric pressure? When the atmospheric pressure is, or its value is higher than 1013 millibars. Of course, a depression means that the atmospheric pressure in this area is below 1013 millibars. Why this number? Because 1013 is the average state of the pressure, the normal state of the pressure at sea level. So if it is higher, it's a high pressure area. If it is lower, it's a low pressure area. What happens with the air around these anticyclones and cyclones? The air moves around these two centers of action, centros de acción que se llaman en castellano. And in the anticyclone, they move like this. In the depressions, they move like this. This means the air goes, in an anticyclone, goes down in the atmosphere. In a depression, the air goes up. And they spin around this anticyclone and depression, but in a specific direction, in the northern hemisphere, in our hemisphere. In the anticyclone, the air moves clockwise. In the depressions, the air moves anti-clockwise. As you can see it, like this, and it also goes down in an anticyclone. In a depression, the air moves like this, and like this. Let's draw it again. Like this, up and counterclockwise. Okay? And now that we know this should be clear. Let's see it in a weather map. The snow glows white on a mountain tonight, not a footprint to be seen. A kingdom of isolation, and it looks like I'm the queen. Okay, so let's draw, I don't know, Spain, the Iberian Peninsula. More or less. My God, this is horrible. More or less, madre mía. This is the Iberian Peninsula. Let's imagine, or let's pretend we are looking at a weather map. We have here an anticyclone, and we have here a depression. And we will see a lot of lines which are called the isobars, which are lines that join the points with the same atmospheric pressure. So let's pretend this is like this, and this is like this, and I don't know, like this. And here another depression, and more or less like this. and we will see the values of the isobars. For example, here, uh, and 998. This means that the atmospheric pressure in each of these points, for example, is 1030 millibars. In all these points, 1026, 1022, 1018, 1014, 10, 6, 2, and 998. As you can see, the closest we are to the anticyclone, the higher the pressure is. The closest we are to the depression, the lower the pressure is. So, how does, or in which direction does the wind blow? We know that the air moves around the anticyclones in a clockwise direction, and the air follows, more or less, the air follows the path of the isobars. So the wind will move like this. Okay? In the depression, the air moves counterclockwise. So the air will move like this. Okay? Like this and like this. So we can say that in this map, in this horrible map, if I ask you from where will the wind blow in this particular day in the Iberian Peninsula, you have to say from north to south. Okay? The wind blows from north to south. And we know this because we are seeing the anticyclone, the depression, and the isobars. And we know what is the direction of the wind. And now I ask you, what is the speed of the wind, the relative speed? It is intense, it is calm. We know that looking at the isobars. If the isobars are very close to each other, for example, these three isobars, this means that the wind will be intense because the pressure difference is high in a small strip of land. So if the isobars are very close to each other, this means the wind speed will be intense. For example, but on the other hand, if the isobars are separated from each other, for example, these ones are very far away from from each other, this means the wind will be calm. And finally, what will be the weather like? We can associate the weather more or less good weather to the high pressure areas and bad weather or unstable weather to the low pressure areas. Okay? So next to the high pressure areas, we have good and stable weather. Stable weather. Next to the depressions, we have bad, unstable weather. This means in the western part of the Iberian Peninsula, we will have calm wind and good stable weather. Probably sunny weather with a very calm wind. But in the eastern part of the Iberian Peninsula, we'll have bad and unstable weather and also windy weather. So probably cloudy or rainy weather with very strong wind. Okay? So let's make a summary. Let it go, let it go. Can't hold it back anymore. Let it go, let it go. Turn my back and slam the door. No, slam the door, no slap the door. Bueno, so let's recap. An anticyclone, the pressure above 1030 millibars, good and stable weather. And the wind will blow in a clockwise direction. Next to the depressions, which are areas with the atmospheric pressure being below 1013 millibars, we will have bad, unstable weather. And the air will blow in a counterclockwise direction. If, well, this, for example, let's say 1024, this is an isobar. The wind, more or less, will follow the direction of the isobars. And if the isobars are very close to each other, let's say like this, 2020, 2016, 1012. If the isobars are close to each other, we will have intense wind. If not, if they are separated, this is relative, okay, from each other, we will have calm wind. Okay, so if I show you a weather map with isobars, anticyclones, depressions, and I ask you what will be the weather like, you have to take into account the atmospheric pressure and the isobars to know if the weather will be good and stable or bad and unstable, and to know the speed and the direction of the wind. That is what I will ask you in a weather map. I hope this is clear, and if not, you can always ask me again. Now let's take a look to the other part of this video, which are the altitude problems. We know that one of the climate factors is the altitude. Why? Because if the altitude increases, the temperature decreases. And the opposite. If altitude decreases, the temperature increases. At which rate? What is the rate of increase or decrease of the temperature according to the altitude? That is the thermal gradient. And the thermal gradient is a constant, which is 0.6 degrees Celsius per 100 meters of altitude change. And as any other mathematical relation, we can also say that the thermal gradient is 6 degrees Celsius per 1000 meters of altitude change. What does this mean? That if the altitude increases 1,000 meters, if we climb a mountain and here we are at 0 meters, we are at sea level, and here in this mountain we are at 1,000 meters. This means that here at 0 meters of altitude the temperature will be 6 degrees higher at this point than at this point. For example, if here at sea level the temperature is 25 degrees centigrade or Celsius, it means that at 1,000 meters of altitude the temperature will be 25 minus 6, 19 degrees Celsius. Okay? And the same if we are going down this mountain. If at 1,000 meters the temperature is 15 degrees centigrade, Celsius, let's say, and at 0 meters the temperature will be 6 degrees centigrade higher. 15 plus 6, 21 degrees centigrade or Celsius. Me gusta más decir centigrade. Okay, now knowing this, let's make some problems. For example, the problem says at an altitude of 1,000 meters the temperature is 16 degrees Celsius. What will the temperature be at an altitude of, let's say, 1,500 meters? So, first, we know that we are climbing, okay? The altitude is increasing, so we know that per 100 meters of altitude increase, the temperature will be, in altitude increase, the temperature, ¿se ve bien esto? No sé si se ve bien, pero bueno. The temperature will be 0.6 degrees lower per 100 meters. So, what is the increase in altitude between these 2 points? It's easy. 1,500 minus 1,000. The increase is, uy, el WhatsApp. The increase is 500 meters. So if per 100 meters of altitude altitude increase the temperature will be 0.6 degrees lower, if the altitude increases 500 meters, this means that we have to multiply 500 by 0.6. And what is the result of this? Zero, 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 3, 0, 0, 0. It will be, espera, aquí algo falla, espera, claro, 0, 0, 0, 0, ¿cómo que 300? ¿Por qué me da 300 esto? ¿Qué estoy haciendo mal? Ah, claro, ya sé lo que estoy haciendo mal, seré imbécil. Forget all of this. Erase it from your mind. So, 500 meters. How many times 100 is contained in 100 is contained in 500? 500 divided by 100, it is 5. And now 5 multiplied by 0.6, it equals 3. So, oh my god, my math. So the decrease, because the altitude is increasing, the temperature is decreasing. there will be a decrease of 3 degrees if we climb 500 meters. Se me va la pantalla. This means that the temperature at 1500 meters of altitude will be 16 minus 3, 13 degrees. And this is the final answer. Let's make another one. Let's say that at 3000 meters of altitude, the temperature is 1 degree. What will be the temperature at sea level, 0 meters? We know that per 100 meters of altitude increase, the temperature will be 0.6 degrees lower. This is the same that if the altitude decreases, the temperature will be increased, will be higher. So per 100 meters of altitude decrease, the temperature will be 0.6 degrees higher. Since we are using high numbers, or very big numbers, we can say that if we multiply per 10 both numbers here, per 1000 meters of altitude decrease, the temperature will be 6 degrees higher. So first, let's calculate the change of altitude. We are going like this. Here 3000, here 0. So what is the difference between 3000 and 0? It's 3000. 3000 minus 0, it's 3000. How many times 1000 is contained in 3000? Let's make a division. 3 divided by 1 is 3. So if we know that the ratio, the thermal gradient, is 6 degrees per 1000 meters, we have to multiply now 6 multiplied by 3, which is 18. So the difference in the increase of temperature in 3000 in a travel or in a trip of 3000 meters in altitude will be 18 degrees Celsius. So if we know that 3000 meters, at 3000 meters of altitude, the temperature is 1 degree, the temperature here will be 1 degree plus 18, which makes 19 degrees Celsius. Okay? It is very easy once your brain makes the tick. You have to know the thermal gradient. 6 degrees per 1000 meters of altitude change, or 0.6 per 100 meters of altitude change. If the altitude increases, the temperature decreases. If the altitude decreases, the temperature increases. Okay? So first you have to calculate the difference in altitude. Okay? First, the difference. You have to make a subtraction. And after that, you have to divide it by the thermal gradient to know how many times the thermal gradient is contained in this change of altitude. After that, you get the ratio, and you have to multiply the ratio per the thermal gradient. So you know the change in temperature. And the last step, you have to add or subtract the temperature to the one that is given at the beginning of the problem. And that's it for these problems. Si alguien tiene alguna duda, por favor, que me escriba. Esto es muy sencillo. Esto último lo explica un poco regular, pero bueno. Si alguien tiene dudas sobre esto, por favor, que me escriba. O al correo, o más cómodo, al aula virtual. Pero esto es muy sencillo, ¿vale? Es saber las altas presiones, las bajas presiones y cómo se mueve el viento en los mapas del tiempo y saber hacer los cálculos para utilizar el gradiente térmico de thermal gradient. Muchas gracias por ver el vídeo, espero que os haya sido útil y nos vemos en el próximo.